The next thing is why we need the formal method. We can prescribe a method and do it manually. Why we need to have a formal method? The reason here we need to have a formal method so that we can develop, based on that, we can develop a computer-aided redesign. The reason is when you work with the redesign of inter-organizational procedure, it's really a complicated process. You deal with a process involved, for instance, like 30 sub-process. Like you just say there are about 30 parties involved in a procedure. So each of them is a sub-process. Each of them has their own sub-process. So we redesign a procedure involving 30 or 40 sub-process. Each of the process belongs to one autonomous party. And each party, they have their own interest. And they can behave opportunistically. So the thing is that if there is a single missing control in a single sub-process, in a single partner, may create vulnerable to the whole procedure. So we need a computer-aided redesign tool to support this complicated and error-prone task. The second thing is more, for me, is more important. Currently, there are many standard procedures, standard secure procedure, like the documentary credit. This is a secure procedure. But the transaction cost is very high because it involves many different banks, many different inspectors, and so on. And this kind of secure procedure is not suitable, especially for a small volume transaction, for specific trading partner, for specific circumstances. So the thing is that by specifying the control requirement and flexible admin control solution, we can design a specific control procedure for specific transaction in specific circumstances to reduce the cost of the total procedure. And this is crucial, this is important, especially for developing country and small and medium-sized enterprises. So what is the result objective? The overall objective of the research includes 4 phases. The first one is modeling the audit process, then deriving control requirements, selecting control solution, and generate new procedure that satisfy control requirements. For this research, the focus is on the first 2 stages. That is modeling the audit process and deriving control requirements. So the objective of the research is to develop a formal method for reasoning about control requirements based on the audit process model. Actually, the objective is dual. The first one is to model the audit process, and the second thing is reasoning about the control requirement. However, in order to achieve the second one, mandatory you need to achieve the first one. So I not say the first one is basically here, but in order to reasoning about the control requirement, you need to have the audit process model, and that must be done. There are no other way around. So that the objective is to develop a formal method for reasoning about control requirement. Imply that also includes modeling about the audit process.
I have a quick question here. So when you finish your PhD dissertation, you're going to just finish the first 2, right?
No, the first 2 is for the dissertation.
Right.
The next 2 things is for the thing that I will try to do with Professor Lee after I finish the dissertation. We try to...
so, yes, first 2 columns.
Yeah. So in order to achieve this objective, I identified 3 challenges. The first challenge is how to model the audit process of inter-organizational transaction. And the solution I propose is to model the audit process in a formalism based on patchiness, the audit logic, and other model logic. We will return to this issue in the next couple of the slides. But the idea is that we use the audit patchiness to model the dynamic behavior of the deontic phenomena. And we use deontic logic and other model logic to model the deontic state. So you have like a right relationship between the 2 persons and so on. We'll be modeling deontic logic. But when you do something to exercise your right, I mean you no longer have the right. That is the dynamic behavior of the deontic phenomena. That will be modeled in the patchiness. The next challenge would be how to identify principle for reasoning about control requirement. Suppose that we have the deontic process, how to derive control requirement from this process, and to by constructor identify the principle for reasoning. Principle for reasoning actually about a set of axioms for reasoning about the deontic process. It will be represented by an if, then. If the deontic process like that, what is the requirement you have? And we will identify based on the pattern of the deontic process. We will return to this issue in more detail. And the last challenge would be how to represent the principle formally, third enabling computer-aided tool to support the redesign. We have the principle in word, that means represent informally, how to state it in a logical form so that we can implement it in a computer environment. Deliverable, as I said, the deliverable of the research is twofold. The first one, what I say is what I call is the deontic process modeling. I temporarily put the subnet DPM just to easier to represent in the chart. The second deliverable is the control requirements reasoning. For the first one, the deontic process modeling, I will delete a formalism for modeling deontic process. I will talk about that more clearly in the next couple of slides. And a set of deontic process model for the domain that I'm working on, that is about the international trade procedure. The second branches of deliverables include principles for deriving control requirements, formal specifications of the principles, and an additional model of the method in a computing environment. Interprop. Interprop is a computer environment for simulation and modeling.
Basically a virtual model.
Yeah, developed by Professor Lee and his associate in the Erasmus University.
Just a quick question here. Actually, you're not using one formal method, right? Actually, you're using multiple formal methods.
Right.
So here you use deontic logic or whatever. There probably use Petronets, right?
Yeah. The thing I use the term formalism here like a collective term, including deontic, including Petronets, deontic logic, and other model logic. But I use
just on this side or
on this side. I talk on this side. I view a formalism here like a collective noun, including the Petronets and deontic logic and other model logic. I will display this a little bit more detail in the next couple of slides. But really, that you're right. It's not a single formalism, sure. The thing is that we collect many different sorts and put it under the name that we call the deontic Petronet. In the XP document, you can capture this term, the deontic Petronet.
How about the right-hand side branch? That side, are you going to do anything on the right-hand side?
Okay, on the right-hand side, I will derive a set of principles, and the second thing is the formal specification. That means to describe the principle formally. I will show some example of this representation.
So the formal specifications will be written using the formal method on the left-hand side?
The formal specification here is mainly based on the predicate logic. This is to describe the process. This is to describe the